let's put this one, boring one, here. Then chlorine, chlorine. How do we make this? Chlorine, chlorine? Anybody? Someone says excess HCl. Anybody else? Any other way? What about this? 1 mole of HCl. What do I form? HCl, I don't know, double bond. So how do I add this? Cis or trans? Do I always get cis or trans, or do I add hydrogen and chloride on the opposite side? What's the rule? Something like this? The hydrogen and chloride are on the opposite side, and then that tells you at the end, is this cis or trans or E or Z or whatever you like. Okay, what else did we cover? That's about it, right? Last time we went through these ones. Now the question here is, how do we get something like this? 4 chlorines on this triple bond. Anybody? Excess Cl2. Nice, okay. Cl2 excess, and that's the mechanism we're going to look over now. So Cl2 excess. So our first one, this is first one, and then our second one, I'll go here. A Cl. Sorry, I'll go this way. Anyway, that's our first Cl. Then our second Cl is just this one here. Sorry, this should be a single bond here. Cl, Cl, something like this. Cl, Cl. So then you make your plus Cl, Cl methyl, and then the chloride. Chloride attacks this one, you get your product. Do you notice that we started from an alkyne and we didn't generate any asymmetric centers? Do you notice that? The alkyne reaction by inherently, the alkyne reaction when you're adding excess Cl2 can never give you asymmetric centers because you every time add 2 chlorines on these 2 carbons, and then those are identical groups. So you can never end up having 4 different groups around carbon. So you don't have to worry about R and S when you're dealing with alkyne because you can never make the asymmetric center. But if I were to split this, say Cl2, only 1 mole, right? I get ClCl, right? And then I say you treat it with 1 mole of HCl. The question is, do we make any asymmetric centers or not? Anybody? People say 1. Do we know what this is? Does anybody recognize this reaction? Here and here? Double bond plus HCl, right? So at the end we can make this Cl hydrogen, right? At the end we'll end up putting chloride on one of these and then hydrogen on the other, and we made an asymmetric center, right? Right here. So there is an asymmetric center there. If I hypothetically pick 1 mole of this and then 1 mole of this, and then yes, I can generate it this way. But if you just pay attention to alkynes and reactivity that Bruce shows you from excess agents, you can really never form one. You can never really form a symmetric center, right? So I will say that that was this reaction. What about this reaction?